So I hope everyone had a good break. Excited to now shift gears a little bit from the high level context and to jump into kind of what people are doing today. And my high level take on what's going on is there's actually a ton of really cool activity that's happening, but nothing that is clearly the winner in the field, which is a really exciting place to be. There's a lot of uncertainty about what ultimately will prevail in terms of the industrial organization across many of these different approaches. And so I'm really excited for where these entrepreneurs and investors are going to evolve in the coming years. So I wanted to put this very detailed graphic up here, which is way too much to read, and I'll break it up into future slides, which is still probably too much to read. But I think the key thing here is that on the technology front, there's a lot of stuff that's actually really mature. The technology works, it's been deployed in the field. And at the same time, across the entire supply chain, there's a lot of emerging innovation, which is really cool. It's one of the distinguishing features of this field that makes it suited for both project finance and for actually deploying big projects on the technology side, but also investing in early stage R&D. And a lot of different approaches, I think, hold very high promise. On the carbon capture side, the basic technology story here is that we've been doing carbon capture for a very long time. We have amine-based systems that work. They just require a lot of energy. There isn't really a way that people have figured out around this, despite decades of research. If you were to attend the Greenhouse Gas Technology Conference ever, it's a global confab of CCS researchers, you will see lots and lots and lots of posters on different aspects of optimizing amine system design. And this is where the world was basically headed in past decades. It's also where we see some of the big projects that exist today. That system that I showed on one of the first slides of the carbon capture at the coal power plant in Texas, that's your sort of classic amine system. From there, you get this whole range of emerging technologies that I think are really interesting on the carbon capture side. And they differ in a number of interesting dimensions. One of those dimensions is on the fundamental chemistry, that people are thinking about new molecules, and we'll get into that in a minute, but actually thinking about how do you bind with CO2 in the air or in a flue gas more selectively, and thus require less energy to separate it. That's the problem, is CO2 is not a particularly unique molecule chemically, and so if you find something that binds to CO2, often it binds quite well and takes a lot of energy to break. It's not very selective. So people are working on that. People are also working on a lot of different sort of reconceptualizations of carbon capture entirely. And many of these approaches are not even carbon capture, but are thinking about how do you produce pure CO2 instead of producing a system that has a mixed flue gas stream. These are things like the alum cycle that we have here. Net Power is a company that's building a demonstration also in Texas that uses fossil energy, but essentially combusts it in a way that produces a pure CO2 stream. So the carbon capture element, again, is less carbon capture, but more how do you just compress that pure CO2. You also have really interesting approaches, cryogenic separation, for example. People are really thinking, I think, in a lot of outside the box ways. I'll save the direct air capture piece once we go into some of the specific companies, But again, this is also a field where people are making innovations among a number of different dimensions in terms of system design, chemistry, and energy use, essentially, on this. Then there's an equally interesting amount of innovation when it comes to the carbon use and the carbon storage field. I think the carbon storage field is actually one that's pretty mature. We've been injecting millions of tons of CO2 for both oil extraction and for simply burying in geologic formations. Saline aquifers are the preferred geology for this. These are essentially oil wells that don't have oil in them. And so they contain a fluid that acts like an oil, which is exactly what supercritical CO2 is. And so it's a very proven technology. We've been doing it here in the US and around the world for decades. That said, there's also a whole bunch of different ways that you can store CO2 beyond putting it into either depleted oil wells or oil wells that never had any oil in them to begin with. And they're really interesting approaches. So you can essentially mineralize CO2 very rapidly in rocks. This goes back to that conversation on aggregates, but people are thinking about injecting CO2 into very different rock formations. There's a project in Iceland, for example, that's injecting CO2 into a basalt. The Carbfix project is able to essentially turn the CO2 into a stone in a number of years, as opposed to when you inject CO2 underground into a saline formation, it takes thousands of years to sort of slowly turn back into rock. These are all really interesting and novel approaches. And it's a similar pattern on the carbon use side. I think the carbon use side has actually been thinking about biological use of CO2 for a long time. Essentially, how do you enhance photosynthesis by providing more CO2 to grow faster? People are thinking about this in the algae context and many of the other biofuel production approaches. And so we've actually seen interesting collaborations between companies that are doing carbon capture and companies that are trying to build biofuel or bioproduct systems by essentially providing that CO2 as another nutrient for biomass production. I want to zoom in back on the capture side first, because I think this is where the field is the most different from where it was when I began exploring this field a decade ago. A decade ago, the consensus amongst nearly everyone who worked on carbon capture was that direct air capture was a complete waste of time and money. That the amount of energy that would be required to separate CO2 from ambient air would simply be so much more expensive than separating CO2 from point sources that we would never do it. There were papers published by the American Chemistry Society that said at best you would get carbon capture directly from air at $600 a ton. Estimates hovered around $1,000 as a reasonable price point. What we see today is that at that time, there were really 4 companies, but 3 still remain, who basically said, no, we actually can do this really well. And they're taking a handful of really different and innovative approaches. Carbon Engineering is the North American leader in my mind. They are essentially using existing technology that they can buy off the shelf in quotes there, but nothing particularly novel itself. What they are doing is simply assembling the technology in a new way and showing that the existing technologies can capture carbon at a radically lower cost than ever assumed. They are on the record saying that they can deliver projects at around the $200 a ton level with their first commercial scale project, which already puts that within a market-ready project based on some of the policy incentives that exist today. That is one end of the spectrum, and many people actually think that there's a technology or a price floor to how low this technology can get, simply because it is so proven and it inherently is not like a radically different technology. Climbworks and Global Thermostat, on the other hand, are trying things that are very different. And so instead of using a tried and true liquid process, they are actually using solid sorbents as their capture material. And that gives them a very different profile in terms of companies and technology. Climbworks is the company pictured earlier. They're mostly commercializing the European market. Global Thermostat has a particularly interesting technology, though they haven't built any demonstrations at or near the size of Climbworks and Carbon Engineering is planning a very large one in the future. But this is a really interesting sample of companies that started about 10 years ago and have collectively raised hundreds of millions in equity from a wide range of investors. The notable company that's missing from here is a company called Kilimanjaro Energy, which a guy named Klaus Lackner started at around the same time. That was an even more radical re-envisioning of what direct air capture could look like, and ultimately was not able to get past some of the commercial and technical hurdles, though that company, or really that technology, lives on at Klaus's lab at Arizona State. So this is kind of the first generation of air capture companies have honestly had a really impressive track record given where the field was 10 years ago, which said this was science fiction. And today most of them are raising project financing. It's not even, is this an equity early stage venture play? It's more of a mature technological deployment and project finance field. I think the really interesting thing about these two approaches is they require very different cost structures. That at the end of the day, a carbon engineering liquid system requires a lot of high temperature heat. And this goes back to the earlier circle of carbon emissions, which is it's very hard to make high temperature heat using renewable energy, and specifically by using electricity. And so as carbon engineering thinks about their system, it's very important for them to figure out how they can optimize that system based on where they can find low cost, high quality heat. The other companies actually have a much more distributed cost structure where they require much lower heat. I think Climbworks only requires 100 C heat compared to I think roughly 900 C heat for a carbon engineering project. And so those companies are actually thinking about where can they locate to essentially use really low cost waste heat. That's why the Climbworks facility in Zurich is on top of a waste incinerator that otherwise would just be venting the heat. They're able to buy that from them at a very, very low cost. These systems also mean that they can use renewable electricity a lot more efficiently. The other really interesting piece about this is that when you have a system that requires such high heat and is designed in the way that carbon engineering has designed it, their economy is really an economy of scale, of unit size. Carbon engineering needs to build very, very big projects in order to get their unit economics to come down a cost curve. The solid sorbent companies, it's the opposite. They're actually building much smaller modules. The Climbworks ones are big refrigerators, large truck size. You can think about it as manufacturing, not necessarily cell phones, but large appliances, which have very different economic and production laws than essentially building large chemical factories. which is ultimately what carbon engineering is going to need to do. So both of the approaches can be modular. The question is, what is the smallest size of the module that actually makes sense? And the answer is that one is, it turns out to be quite large, and the other is much smaller. So it's really interesting because Klaus Lackner, the fourth direct air capture company, has actually looked into this. And the evidence suggests that ex ante, you can't tell which of these approaches is better, that there have been economies of scale from unit size as well as economy of scale from manufacturing quantity. There isn't a right answer. It's just figuring out how to get that deployment-led innovation happening so you can do the learning. I think that's really interesting because it really contrasts with the renewable energy production field that has taken off. Almost all of that falls into the solid sorbent category of much smaller modules that benefit from very large manufacturing efficiencies, whereas we've seen things like liquid natural gas requiring enormous terminals in order to be effective. And so you just have very different industrial structures that are suggested by the technology configurations today. The other really important piece of this is that, again, a direct air capture system is not inherently a carbon removing one, and it can use any type of energy. And so this is a graph that Jen Wilcox's lab produced. Jen is one of the leading scholars on this. She's now at UPenn and has studied this in great detail. She led the National Academy's panel on the direct air capture space a few years ago, and shows that it really depends on what energy you are using that drives many of these costs. And so a lot of the innovation in the direct air capture space I expect in the near future is going to be on project development in many ways, figuring out how you can put together the different components of a project so you get really cheap electricity, really cheap heat, and are able to do something with your CO2 in a cost-effective way. There are just a lot of moving pieces, and it's a pretty complex financial puzzle to put together, but one that many folks are working on. As I mentioned, carbon engineering is I think really leading the field, at least here in the US. They've signed a deal where they've gotten strategic investment from a lot of oil majors. Occidental Petroleum has been the lead in kind of promoting the carbon engineering approach. They are looking to develop a project in West Texas right now. I'm not sure the extent to which it's on hold given coronavirus and oil prices, but it was initially designed to be a 1 million ton per year plant that would be used to produce both oil and sequester CO2 directly. So again, 1 million tons per year is not an insignificant project. It's actually quite large in a field where this is the Climbworks facility. This is about 1,000 tons per year that come out of these dozen or so modules in Switzerland. So very, very different approaches. And it's also very interesting that Climbworks, the European company, has not taken any strategic investment from oil majors at all. It has taken strategic partnerships with transportation providers. I think it's working with airlines. It has a deal with Audi to produce air to fuels, essentially, for next-gen vehicles. But the two companies are approaching the commercialization pathway in interesting parallels, but are going about the production very differently. Global Thermostat also has really interesting technology. They've really reconceptualized the air contacting design in ways that are really innovative. And I think it has the potential to drive down the cost of carbon capture, both at point sources and directly from the air, very substantially. this company just hasn't had the traction to actually build projects at the same scale and attract the investment. Though I still think the technology itself is really interesting. There's also been, in parallel to those direct air capture companies, a lot of innovation on the point source capture side that is overlapping with direct air capture in a really interesting way. Sponte, formerly Inventus, is a company that's based in Vancouver. They have a carbon capture system that rotates, a very novel design. Their technology has been scaled up in Canada in the context of kind of remote CO2 for oil extraction in that context. But I think they are working to build some of the early projects that would take advantage of the 45Q tax credit here in the US, because their technology is likely within that price point for some of these early carbon capture approaches. We've also seen more recently, really within the past 5 or 6 years, a number of other companies that I think offer potentially path-breaking advances, even if they're not developing entire systems themselves. So I mentioned Arizona State University before. They actually have interesting commercialization agreements on some of the mechanical carbon capture technologies it's based on a humidity swing. So not even an electro or thermochemical system as many of the other companies are. Part of the reason why they're located in the desert in Arizona. But they just have a wide range of innovations that they have some early ARPA-E grants that I think could be truly transformative in what some of these technologies are doing. We also have groups like Mosaic Materials, which I mentioned earlier. There's folks working on different materials that can be much more selective and thus require a lot lower energy to do carbon capture and storage. And I think that this holds a ton of promise in the broader field. I think this can, especially in systems where this is the main cost driver, the material science innovation can be really important. We also have companies that I think are still at the very, very early stage. A company like Verdox out of MIT has an electrical process that's very, very different from many other carbon capture and storage approaches. And we also have similar, more academic efforts in Europe, Skytree and Solitaire in the Netherlands and Finland, respectively. So I think the ecosystem here, even if these folks are not developing large-scale projects in the same way that some of the older direct air capture companies are, they hold a lot of interesting promise, either to leapfrog some of those developers that have kind of more technologically ready but less innovative approaches, and or become component suppliers to some of those companies. Moving away from the emerging carbon capture landscape a little bit, what we've actually seen is there's a lot of interest and a lot of capital flowing to some of the carbon utilization companies in the built environment space. And so I didn't include the whole range of carbon use companies that are focusing on fuels or chemicals or some of the other things that might not sequester carbon, but are more of a reduction in carbon approach, because there actually are a handful of storage innovators that are selling a valuable product and sequestering carbon. Solidia and CarbonCure are probably the more mature companies when it comes to actually selling a finished product, taking very different approaches. Solidia focused on precast, CarbonCure on the cement that can be laid in roads or airports or other types of larger infrastructure projects. And Blue Planet is actually working on the aggregate piece of this. And that's their innovation, is less on the cement side and very much more on the aggregate and concrete side. So I think it's a really interesting approach here. Again, I mentioned that this field is really, really hard because there's almost no green premium for these innovators, and there's a lot of hesitation to adopt novel technologies. I think the thing that is really interesting is we're starting to see increased interest in decarbonizing building materials. California has new procurement standards for the state's purchasing that requires low embodied carbon when it does procurement. Cement was initially, and concrete were initially exempted from this standard due to lobbying pressure, but I anticipate that over time we'll start to see more and more jurisdictions have these buy clean initiatives that are essentially trying to measure the carbon embodied in our built environment and to slowly drive that down in the same way that we have that same pressure on our transportation sector, on our power generation sector, and could be a really important regulatory signal to get companies buying. The other piece of this chain is that there's a huge amount of promise coming from the public sector. When we started as an organization at Carbon180, there were very few opportunities for innovative carbon capture. The Department of Energy by law was required to spend their carbon capture money on coal power plants, for example. And so you didn't have a lot of really innovative research. I think that's all starting to change and starting to change very fast. ARPA-E now has a handful of programs that are focused on different pieces of the carbon capture and sequestration value chain, whether it's through algae and macro algae in the ocean, in the Mariner program, figuring out how to do carbon capture and storage in flexible systems, thinking about a power sector that's 80% renewable. You need very different types of carbon capture on that last 20%, if that's where it ends up being most valuable, than you would if there were 20% renewables and you needed 80% carbon capture, for example. And then they're also doing a lot of work on the agricultural side, figuring out how to support not just the innovative biology for carbon capture, but the tools to measure and verify that, which we'll get to in a bit, is really essential. The other thing is that ARPA-E tends to get a lot of the press and the praise from the broader DOE innovation ecosystem, but there's a handful of other efforts going on outside of that program specifically, including of all places, the Office of Fossil Energy, which just this year made 18 grants for new direct air capture companies. And they're just, I think, very excited about the future. Those are all very early stage technologies. And the cool thing for me is that I knew very few of those companies and researchers, which means that once this money does start to show up, that people are going to start coming out of the woodwork with really innovative ideas. And the funding, I believe, was TRL 2 to 3, so very early stage. And what the Department of Energy, I think, is planning for is a future where they're building for a carbon shot in the same way that they're building a sunshot program of decades past, where they're starting with a lot of really innovative early stage technologies and are going to try and over time find technologies that can meet market demands and support those at bigger and bigger demonstrations. So I think a lot of really interesting things happening here. And this is just the tip of the iceberg. Programs like Cyclotron Road and Activate have supported a number of carbon capture use and storage companies in the past. And I think we'll start to see a lot of really interesting innovation happening across the broader DOE ecosystem. And this is one of the things that we're hearing from investors, is that many times they do not want to support some of these really high risk research projects that rewinding a few slides, all of the direct air capture companies that emerged here in the US had billionaire backers, and they could afford the very large research expenditures that are required early on. That's not common in Silicon Valley. And so I think so many investors are looking for this early stage R&D support so that they can, once the technology risk gets reduced a little bit more, they can then help with the market and product risk. I also wanted to talk a little bit about the agricultural carbon removal space. I mentioned at the top that we didn't really need new technologies in this space, that we knew how to sequester carbon in soils, we know how to plant trees. But just because we don't need new technology doesn't mean there aren't folks that are working on really innovative ways to make this more cost effective and change a lot of the products and the economics of farming in such a way that we don't have to pay people to do practice change. They will just find that that practice change is something that is in their economic interests. A lot of the approaches are very different. We have some that are working on the genetic modification. There are two main routes here. Some folks are thinking about how do you modify the plant to be more photosynthetically efficient and thus be able to produce more per unit of land and, in theory, sequester more carbon that way. Then there's a lot of very innovative approaches about fundamentally changing plants to be able to sequester more carbon. So the Salk Institute is leading a very large project thinking about how to re-engineer roots so that they sequester carbon in a more efficient and effective way. Other efforts are thinking about how do you perennialize annual crops. This would, in effect, eliminate a lot of the tilling and replanting requirements that end up disturbing soil and releasing carbon. And so there's a lot of really interesting opportunities to think about how we might be able to perennialize early things like wheat that would fundamentally change the relationship between farming and local ecosystems and actually return it to a much similar state where a lot of that farming happens in places that were formerly grasslands and prairies. And so there's a way to essentially think about regenerating those ecosystems in a way that's still agriculturally productive. Then people are thinking not just about the plants, but about soils. And so there's a number of companies who are thinking about how do you create microbial fertilizers, and that these fertilizers can have a wide range of effects, but carbon storage is one of them. And thinking about how we can essentially apply additives to soils that sequester carbon. And the microbes that people are using are incredibly varied, from photosynthetic microbes to microbes that enhance the mineralization of soils. Like the range of different approaches is really wide and broad, and I think really interesting. The last company I'll mention is that there's been a really big push from the academic community around using biomass coupled with carbon capture and storage. So far, this has not been something that has been actively embraced by many entrepreneurs as a carbon capture and storage approach outside of the traditional ethanol industry. Charm Industrial is taking a really interesting approach where they are making a bio oil, but instead of then refining and burning that biofuel, they're simply burying it underground, which to many people I think sounds crazy, because why would you bury oil when we are spending hundreds of billions of dollars every year trying to find and extract more oil? But it's a really interesting reconceptualization of what bioenergy with carbon capture and storage can be. And I think we're going to start to see a lot of really interesting approaches on that front as well. The other place that we're seeing a lot of really interesting innovation is on the forest and harvested wood product side. So this really spans a lot of different industries. There's not a clear place that I would place this, because sure, the forest products industry is a big piece of the agriculture, forestry, and land use equation. But this picture on the right is of something like an 18-story wood structure in Norway, and at the time was the largest high-rise that was made of wood. And the forest products industry is thinking about how they can really replace a lot of cement and steel that currently produces a lot of carbon with wood. And if the building lasts for decades, if not centuries, that wood is essentially reliably sequestering the carbon if the forest management is done in a responsible and sustainable way. There also are a lot of folks thinking about, given that we're having lots of forest fires, we've degraded ecosystems all around the world, how do we speed up the regeneration of those ecosystems, especially because many of them are not currently being utilized for the initial purpose. So I think the northeastern US is a great example where we deforested vast swaths of the Northeast in order to do agriculture when we first settled the country. All of that agriculture then shifted to the Midwest, and there's been a huge amount of increase in forest cover and thus carbon sinks over the past century in the Northeast. A lot of these companies are thinking about how do they speed up processes like that through drone replanting and thinking about accelerating and reducing the costs of reforestation. There's also really interesting innovation happening on the bioengineering side. Companies like Living Carbon are thinking about engineering better trees, but we're also seeing that happening in the lab. People are working to bring back the American chestnut as a agricultural forest product. And people are thinking about forests outside of the terrestrial ecosystems. Running Tide is thinking about making large kelp forests and essentially burying that kelp deep under the ocean, where it would, in theory, stay sequestered for a long time. And so with all of that innovation taking place, and that's really only a snapshot, I think I learn about new efforts happening every day, we're starting to see capital flow in a major way. And that capital is coming from a very diverse set of places. We've seen it all the way from early stage startup accelerators like Y Combinator to very large strategic investors in the oil and gas sector like BP, Shell, Exxon, et cetera. Not only are we seeing it from the large companies that have a direct stake in this, in the fossil ecosystem, but we're also seeing it from a lot of the investment funds from these tech companies. We're seeing that the Microsofts, Amazons, et cetera, are not just buying carbon removal services, but they're thinking about investing in that as well. And so we're seeing the ecosystem start to get a lot more support, and it's really encouraging to see that investment really start to flow in. I just wanted to close out this section. I know we need to head into another break here in a minute, but there actually are a number of really interesting emerging resources for investors in this space. XPRIZE recently launched the Circular Carbon Network. It's this huge database of companies, investors. Many of it is focused on the CO2 use and CO2 utilization, but you'll also see a lot of the carbon capture companies there. And I think it's a great resource for folks who are looking to get an even more comprehensive picture about what's going on, especially on the tech side.